The aim of this video is to show some of the features I've implemented during my Google Summer of Code project to ghc-mod. And what is ghc-mod? It's a minor mode for Emacs that enhances Haskell development. So to show you new features I've been working on, I'm going to work on this file you can see on the screen. So you can see that right now there is just some definition of a binary tree data type, some small function that creates a tuple out of a value by duplicating it, and then a function f that we would like to write. So right now the function f is highlighted, and why? Well, if we put the mouse over it, we can see that it lacks an accompanying binding. So we would like to write a function, and one of the features that are new is that now you can create the skeleton of a function from its type signature just by pressing Ctrl U meta T. So you can see that there is a body of a function. So I set the file to go into the compiler again, and you can see that now some new something new is going on. We have this thing underlined in purple, and if you look at it, it starts with an underscore. So what it is, it's one of the new features that have been introduced in ghc 7.8 that are called holes. So what's a hole? A hole is a placeholder for some code that you want to write afterward, but you don't know yet what it should be. And this leads to a new way to develop your programs in incremental steps. And ghc-mod now includes extra support for working with this hole. So we can go to the next hole in the Emacs session by using Ctrl-C meta N, and you can see that now we have the information about the hole shown in our window. You can see that we have found a new hole, and it should have type maybe A to A. And there is also a list of relevant bindings, which are things that the compiler thinks that may help you write in this function. Anyway, okay, we have this information. We will hide it by using escape several times. Okay, and now let's try to see how we would write this function now. So another nice thing is that in many cases you want to pattern match on a value. So now ghc-mod also helps you doing this. And how does it? So if you go on an argument name and press meta T, then it performs a case splitting for you. So you can see now automatically we have split it between case nothing and the case just X, and the holes show this new information. So now the information we have, for example, here is that X is now of type A, not of type maybe of A as it was before. So now that we know this, let's try to write the case for the jest. But instead of just deleting what we have there and writing what we want to do now, what we can do is try to refine our code. And what is to refine? Try to call different functions and put new holes for those arguments. So we can run refinement with Ctrl-C, Ctrl-F, and you can see that now it asks for some function to refine. So in our case, for F, we know in the just case that we need to return another just. So we will refine with just, with this function. Okay, and now you can see that there is a new argument to be included here. So now what can we do? Okay, we can try to figure out what should be the type of this, and we can see that it should be a tuple of A, and we have just a function duplicate which allows us to get this. So what can we do? Okay, we can continue to refine using now this function duplicate. Okay, and you can see that ghc-mod takes care of putting parentheses if they are needed, like in this case. So what we have left is another element that we should include. So let's see what is their type. So we have to find something with type A, and we have something of type A with X. So we can finally finish our function by putting an X here. Great. So now we have been incrementally refining our program by using this splitting on values and then incremental refining over the wholes. An extra nice feature is in some cases there are not many possible definitions for a function, and for this case there is a nice tool called Gene, which allows you to explore the world of all possible programs that you can write and find out what fits your types. And ghc-mod also integrate this into your Emacs workflow. For example here, well, the only thing you can do is write nothing, and this tool is able to find it for you. So let's press the key to get the gene completions, which is Ctrl+C, Ctrl+A, which stands for auto completion, and see what happens. So nothing has been written for us because that's the only possible definition we can find here. So that is very nice. You can get information about what the type of your program, what the types of the values in your whole should be, and you can also try to ask the gene for possibilities for this. Actually, instead of writing F as we have been doing this by splitting and refining, we can start with the body again, and now let's try to call the gene on this. So Ctrl+C, Ctrl+A, and as you can see there are possible completions here. So these two are two possibilities. We can always return nothing, and this is the possibility within programming, and well, sometimes it also outputs some garbage, but usually the first one are the nicest. And so if we want to include this one, we will just click on this, and you can see you have automatically written the implementation for fx. So this is really nice. So now let's continue to see the new features. So it may look that this case splitting only works for the cases where you have like maybes or lists, something that is already known, but ghc-mod is also able to split on your written data types. For example, this binary tree that I've written here. So let's try to write some tree with this new workflow. So we want some function like this, which goes from binary trees of integers and returns just an integer. So let's save it, and now we have this problem that we don't have a binding for this, but we can create a new skeleton of a body by using Ctrl+U meta t. So we can see here that we have the new body. And what are their types? So let's look at it. So we need to get an integer, and we have a tree of integers. So what can we do? The only thing we can do right now is split it on x. So let's do this. Remember, meta t, and you will split. And you can see that some new names have been created when you have more than one argument. So now let's see what we can do. So let's try to call the gene here. Okay, it doesn't show any possible completion, so we will do it for it. So let's include here x, and here we have to include x1 plus some tree of x2 plus some tree of x3. Okay, so now everything is nice. It will be also very nice if it could help us write in instances of type classes, and it can do this. For example, let's say we want to include an instance for equality on binary trees. So we write the declaration. So let's see. So now there is a problem here because there is no implementation. So we can press the same thing we used to create an initial binding for a signature in this type plus instance declaration. So let's call Control U meta t, and we can see that the new body of these functions are created. So by default it includes all the things that you can overload, and of course everything works. So you can see that what are the bindings, or you can try to split on it. So that was mostly all. This is the result of my work, so I hope it comes handy for you when you are working on Haskell and Emacs. Thanks for listening.